Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on probability, lecture number 16, in which I will solve some more problems on independent events. Now we solve a problem. Problem is, let A and B are two events such that probability of A equal to half, probability of A union B equal to 3 by 5, and probability of B is small p. Find small p if they are, number 1, mutually exclusive, number 2, independent. Now we solve number 1. In number 1, we see that A and B are mutually exclusive. Then A intersect B equal to 5, null set, empty set, implies that probability of A intersect B equal to probability of 5. Probability of null set is 0. Therefore, if A and B are mutually exclusive, then PA union B equal to PA plus PB. PA means probability of A. Here probability of A intersect B is 0. Implies that probability of A union B is 3 by 5. Probability of A is half. And probability of B is small p. Implies that small p equal to 3 by 5 minus half equal to LCM 10. Here 6 minus 5. This is 1 by 10. Now we solve number 2. Number 2, given that A and B are independent events, then we know that PA intersect B equal to PA multiply PB. PA be the probability of A. Since formula for total probability be PA union B equal to PA plus PB minus PA intersect B. Here PA intersect B equal to PA multiply PB, since A and B are independent events. Implies that this is 3 by 5, this is half, this is small p, minus PA is half and PB is small p. Implies that 3 by 5 minus half equal to P minus half P, means half P. Here this side 1 by 10 equal to half P. Implies that P equal to 2 by 10, means 1 by 5. So our problem is solved. Now we solve the next problem. Problem is, a die is tossed thrice. Find the probability of getting an odd number at least once. During tossing of a die, odd numbers are 1, 3 and 5. Since die is tossed thrice, let A be an event to appear odd number in first toss, B be another event to appear odd number in second toss, C be another event to appear odd number in third toss. Since probability of A will be half, and probability of B will be half and probability C will be half, because odd numbers are 1, 3, 5 and even numbers are 2, 4 and 6. Half here. Probability of complement of A equal to 1 minus probability of A equal to 1 minus half equal to half. Probability of complement of B equal to 1 minus probability of B equal to 1 minus half equal to half. Probability of complement of C equal to 1 minus probability of C equal to 1 minus half equal to half. Since A, B and C are independent events, probability of at least one of A, B and C, that means at least one odd number appears, and this equal to probability of A union B union C, and by complementation rule we know that probability of A union B union C equal to 1 minus probability of complement of A multiply probability of complement of B multiply probability of complement of C, for A, B, C are independent events. And here 1 minus probability of complement of A means 1 minus probability of A. Probability of complement of B means 1 minus probability of B. Probability of complement of C means 1 minus probability of C. And this equal to 1 minus, here 1 minus half, here 1 minus half, here 1 minus half. This equal to 1 minus half multiply half. This equal to, here LCM 8, 8 minus 1. This is equal to 7 by 8. So, our required probability is 7 by 8. Hence, problem is solved. Now, we solve the next problem. Problem is that in a girls' hostel, 60% of students read Hindi newspaper, 40% read English newspaper, and 20% read Hindi and English newspapers, both. A student is selected at random. Number 1, find the probability she reads neither Hindi nor English newspaper. Number 2, if she reads Hindi newspaper, find the probability that she reads English newspaper. If she reads English newspaper, find the probability that she reads Hindi newspaper. Now we solve this. Solution. Let H be the collection of students who read Hindi newspaper. E be the collection of students who read English newspaper. Now, probability of H. Here H is an event which is the collection of students who read Hindi newspaper. Here given that 60% of students read Hindi newspaper. So probability of H equal to 60 by 100, and this will be 3 by 5. Probability of event E. Here 40% read English newspaper. So probability of E is 40%, means 40 by 100, and this is equal to 2 by 5. Here 20% read both Hindi and English, means probability of Hindi and English, that is probability of H intersect E is 20%, means 20 by 100. And this is 1 by 5. Now, number 1. Find the probability that she reads neither Hindi nor English newspaper. Means not Hindi. Not Hindi means complement of H. Not English means complement of E. So, this is probability of neither Hindi nor English. Means probability of complement of H intersect complement of E. And by De Morgan's law, this equal to probability of H union E complement. And this equal to 1 minus probability of H union E. Since by total probability P H union E equal to PH plus PE minus PH intersect E. Here this equal to 1 minus PH. PH is 3 by 5. PE is 2 by 5. And PH intersect E equal to 1 by 5. And this equal to 1 minus, here 5 LCM, 3 plus 2 minus 1. Means 1 minus 4 by 5. And this is equal to 1 by 5. Number 2. If she reads Hindi newspaper, find the probability that she reads English newspaper. This is the case for conditional probability. Means if he reads Hindi newspaper, means already known that she reads Hindi newspaper. We have to find the probability that she reads English newspaper. Means known event is H. We have to find the probability of E slash H. So P E slash H means probability of E intersect H by probability of H. We know this formula. And probability of E intersect H is 1 by 5. And probability of H is 3 by 5. That is 1 by 3. Now, number 3. If she reads English newspaper, means event E is known. We have to find the conditional probability of H when E is known. Means we have to find probability of H slash E. H slash E. This is equal to PH intersect E by PE. PH intersect E equal to 1 by 5. And PE is 2 by 5. And this is equal to 1 by 2. So our problem is solved. Now we solve the next problem. Problem is E1 can hit a target 4 times in 6 shots. E2 3 times in 5 shots. Whereas E3 2 times in 4 shots. Each of them fire shots. What is the probability that number 1 exactly 2 shots hit the target? Number 2, none hit the target. Now we solve the problem. Here given that E1 can hit a target 4 times in 6 shots. Therefore probability of E1 equal to 4 by 6. E2 3 times in 5 shots. Probability of E2 equal to 3 by 5. E3 2 times in 4 shots. Therefore probability of E3 equal to 2 by 4. Now We solve number 1. Exactly 2 shots hit the target. Exactly 2 shots hit the target means first shot hit the target, second shot hit the target, and third shot does not hit the target. Or first shot hit the target, second shot does not hit the target, third shot hit the target. Or first shot does not hit the target, second shot hit the target, third shot hit the target. Since first shot hit the target and second shots hit the target, both are independent events. Similarly, 3 shots hit the target are independent events. Therefore, probability will be probability of first shot hit the target and second shot hit the target and third shot does not hit the target, plus probability of first shot hit the target and second shot does not hit the target and third shot hit the target, plus probability of first shot does not hit the target and second shot hit the target and third shot hit the target. Means all are mutually exclusive. So here we have written plus. Now we know that first shot hit the target, second shot hit the target and third shot hit the target are all independent events. So here P E1 intersect E2 intersect complement of E3 equal to Pe1 multiply Pe2 multiply P complement of E3. Similarly, here also Pe1 intersect complement of E2 intersect E3 equal to Pe1 multiply P complement of E2 multiply P E3. Here P complement of E1 intersect E2 intersect E3 equal to P complement of E1 multiply P E2 multiply P E3. Now in place of P complement of E3 we write 1 minus P E3. In place of P complement of E2 we write 1 minus P E2. In place of P complement of E1 we write 1 minus P1 here and we put the values. Pe1 is 4 by 6, Pe2 is 3 by 5 and 1 minus Pe3, Pe3 is 2 by 4 plus Pe1 4 by 6, 1 minus Pe2, Pe2 is 3 by 5 multiply Pe3 is 2 by 4 plus 1 minus Pe1, 1 minus 4 by 6 multiply Pe2 is 3 by 5 multiply Pe3 2 by 4. So this will be equal to, if we take LCM, here 6 multiply by 5 multiply by 4 and we write all things. Here 4 multiply 3 multiply 2 plus 4 multiply 2 multiply 2 plus here 2 multiply 3 multiply 2 and after calculation we may get this equal to 13 by 30. Now we solve number 2. None hit the target. None hit the target means probability of E1 union E2 union E3 complement. That means 1 minus P E1 union E2 union E3. Since E1, E2, E3 all are independent events, therefore by complementation rule this equal to 1 minus P complement of E1, P complement of E2, P complement of E3. Here 1 cancel, here remains P complement of E1 multiply P complement of E2 multiply P complement of E3, and this equal to 1 minus PE1 multiply 1 minus PE2 multiply 1 minus PE3. We write the values. 1 minus 4 by 6 multiply 1 minus 3 by 5 multiply 1 minus 2 by 4, and by calculation we get this value is 1 by 15. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.